Hello Internet, I am Mhamed Elmezoued and I will show you the different steps we made to create the crowd of the dark creators who chased Barbara in the first sequence of this trailer. First, let's watch a game footage of Rayman Legends that we use as reference to analyze the motion and behavior of the little beasts. We can see here that the creatures always move together and are very compact. They rarely stand out of the group, and if they do, they quickly come back in. We can see also that there is a kind of convective motion. We can see here they always move in circle, like the caterpillars of a tank. Okay, how to do this in 3D? Here are the big steps. First, we start by animating a simple placeholder of the crowd. Then we use this placeholder to contain the ParticleFlow system. When the simulation is complete, we bake the animation of particles on Helper in order to have a lighter and quicker scene. Then we link an instance of a low version of an animated dark creators on these helpers. We had a few hard versions of keyframe animated dark creators in the foreground, and of course the character of Barbara. And voila, we just need to hit F9. Okay, how did I design the process? How to keep the dark creatures in compact way during the shot. When I watched the references, I immediately think of the log-bound operator in ParticleFlow. This operator ensures that the particles remain together and are connected to a static or an animated surface. I will come back to it later. The first thing we have made is animate a mesh. This mesh in the viewport, which look like a soft body, that helps us to determine the volume of the crowd. This animated mesh is actually a simple sphere, as you can see, that we put in motion with the space warp FFD box. I hide the set to be more clear, and I hide the control. This up there is the FFD box. This FFD box is skinned with shapes and helpers as a bond. This little setup has allowed the animator to easily manipulate and twist this sphere in the viewport. That was more handy than if we had to use the FFD box control points. The yellow shapes, it's to control globally the shape of the mass, and the helpers to fix locally the silhouette of the mesh. For the rotation of the sphere, we just use a wire parameters to link the X and the Y position of the global controller, the blue one, with the sphere rotation in X and Y axis. And you can see when I move this controller, the sphere rotates. So when I was happy with the animation, I use this animated mesh to contain all my particle system. Let's go see the ParticleFlow setup. Okay, how did I design the ParticleFlow setup? I have already set up the scene in order to be more clear. The particle system, as you can see, is quite simple. The key points are the log-bound operator there and the physics switch or MassFx switch, and a little trick with the shape facing. That we'll see later. Let's go see the particle. I had the set to be more clear and put this mesh transparent that you can better see the particle. First, we start by creating an empty flow in which I put a birth operator. This birth operator will allow the emitter to generate 100 particles from frame -20 to frame -20. So, as you can see in the viewport, at the frame -20, all the particles will created at the same time. Next, I use a position object in order to ensure that the particle born inside my animated mesh. You have to click on Add and pick your mesh in the scene. Next, you have to specify a location. I choose volume to fill the volume of the mesh, and check the animated surface because we have a moving object. After that, we have to give a shape to the particle with the shape operator. You can choose between the several presets. For this example, I choose a simple cube. From now on, if I launch the playback of the shot, you can see that the particle do not follow the animated mesh. How to fix that? For that, I'm going to add a logbound operator. And if I launch the playback, you can instantly see that the particles are now following the mesh. The result is not so bad. All my particles are moving and following the animated mesh. Let's go see what the logbound operator is made of. For the explanation, the role of this operator is to force the particles to stay at their position while following the animation of the surface on which they are attached. Therefore, when the animated mesh is moving, you can see that the particles remain at their position inside the mesh while being driven by his motion. In the operator here, I specify that the particles are attached to my animated mesh, and we have to click on add and pick the object in the scene. Next, we have to click on the lock to surface and specify animated surface, because here we have an object with an animated surface and not a simple moving object. For now, we can let the other options as default. Okay, the result is not so bad, but if I increase the number of particles, it will be more clear. You can see that the particles intersect with each other. This is the next step, how to solve that interpenetration problem while keeping our animation. For that, we are going to add a dynamic collision in this particle system. We start by creating a physics world. This operator is going to specify that the particles of this event are now part of a dynamic world with physics simulation. For this, you also need to add a physics shape operator. This one will establish a collision surface for each particle. It can be a box, a capsule, a sphere, or even better, a convex hull. Convex hull will be an approximation of the particle geometry. In this case, we choose the sphere option. If you want, you can check a preview of this collision surface in the viewport as a shaded geometry or wireframe. So let's see what's happened to my particle. What happened on frame -20? As you can see, with dynamic on, it's a bit of a mess. Actually, the logbound operator does not do his job anymore. What we need to do is maintain the particles inside the mesh while ensuring they do not intersect each other. To do that, we had a physics switch operator. This operator allows ParticleFlow to take into account both universes. First one, the motion driven by standard operator, in other words, kinematic. And second one, the motion driven by physics simulation, or in other words, dynamic. In brief, with physics switch, ParticleFlow is going to take the best part of each situation. It will adjust the motion of the particle with the properties of standard operators. It's quite simple to set up. We need to specify that we want to match the speed, the position, the rotation, and the spin of all the particles. We can see then that the particles do not interpenetrate anymore and stay attached to the animated mesh. Let's see from camera view. I reduce the number of particles so that it is quicker to compute and launch the playback. This is not bad and similar to the results I'm looking for. But if I change the shape of the particle from a cube to something on which we can determine its orientation, let's say a little heart, we can notice that the particles are looking in every direction. This is not what we want. They are chasing Barbara. We want them to look at her. We are going to cheat a little to that. We add a shape-facing operator. I turn off my heart and turn on shape-facing. This operator allows to create planes that look towards the camera or an object. If I grow the size, we can notice that the particles are looking at us. Actually, I tell them to look toward an object. This object is hidden and is nothing more than a helper linked to the head of Barbara. If I look from the left view and move this helper, you can see, that the planes are always looking toward this object. But we do not want planes as a particle shape. The trick here is to put on top of this shape facing another shape operator. This operator will inherit the orientation property and obviously the scale of the shape facing. Put one in scale, and so that I have my little hearts back and they are looking in the right direction. So if I go back to the camera view and launch the animation, I can see that my particles follow the animated mesh and they look in the good direction. Great, but if I unhide my set, we can see that there is one more thing to do, because my particles interpenetrate with the ground. To fix that, we call the MassFx collision operator to rescue. We tell him what are the objects that we want as deflectors. For that, we have to add on those objects a PFlow collision shape modifier that can be found in the world space modifiers category. PFlow collision shape. In the modifier, we have to tell him how to translate the geometry for the dynamic engine. You can choose here different primitive shapes, but for a better result, you have to choose geometry. It will respect the exact topology of your object. Now click on Activate and add this object on the MassFx collision deflectors list by clicking on Add and pick in the scene your object. Up, up. It seems that we have everything well set up. I hide this animated mesh to see only the results of my particle. As you can see, they move without interpenetrate with the ground or each other, and they follow the motion of the animated mesh. Let's see the results. This is the preview. There is around 300 particles. Now we need to replace those hearts by the dark creators. If we have a look to the scene, with only 100 particles, this is quite slow. I need to optimize this. One solution for that is to bake the particles onto helpers. To bake particles, I use the PFlow Baker script made by Offer Zalikover. It's very simple. You have to specify the particle system you want to bake. Here I have only one particle system, so that is already selected. Then you have to specify the range, the frame range, and finally you choose what kind of result you want. I don't need the particles mesh, so I check helpers. Then we need to uncheck this, and this, and we can launch the process. For each particles, the script will create a helper with an animation key at each frame. After that, we can delete the ParticleFlow system and only keep the helpers. Well, here is the result when it's done. Same simulation, but with helpers only. What is the next step? On each helper, I am going to link a low resolution mesh of a dark creature. Let's go see what she looks like. I have already set up a creature with a point cached animation cycle. This is a low version of the dark creatures. Actually, for this crowd, we don't need and we don't want to have a heavy mesh. This is the same for the fur of the creatures. It is a real fur setup on the height version, but for the crowd, we decided to use a technique already used in video games that involved to transform the fur in alpha texture on planes. In the end, we have a much lighter dark creature who fit perfectly for the crowd situation. To make a difference between all the creatures, we just have to offset the animation cycle between them. These 4 creatures will replace the helpers thanks a little script that I made. I call it distributor. This script randomly copies a selection of objects onto another selection of objects. I put my 4 creatures in the source list and put the helpers in the destination list. I need to check instance mode and scale, rotation, and position so that the creators will take this information from the helpers. And then I click in distribution to launch the process. Now we can see that the script passed the creators on the helpers. I can hide this, and this. And let's see what it looks like. Here is our crowd of dark creatures, baked and point cached. And this is quicker than the ParticleFlow system that we had before. Okay, now it seems like it's over. Let's do a recap of what we made. We attach a dynamic particle system to an animated mesh. To optimize our scene, we bake this particle system on helpers, and we replace the helpers with point cached animated low resolution dark creatures. And voila! Next step will be to put that in the lighting scene, then to add a few high resolution dark creatures in the foreground with real fur made with air farm, and of course to add Barbara. Press F9 and thanks to magic, here is the final shot. You can barely notice that we use low resolution dark creatures in the crowd. This is it. Thanks for listening to me. Thanks to everybody who worked on this project, and thanks Autodesk. See you!